We're going to follow the full MLOps journey, turning raw data into trained models, deploying them reliably, monitoring performance, and feeding improvements back into the system. MLOps is the operating model that keeps machine learning useful in production. You've already connected machine learning with automation, deployment, monitoring, CI/CD, cloud infrastructure, and containers. Now we'll bring those pieces into one lifecycle view, so Module 2 can turn the concepts into a hands-on production workflow. Think of MLOps as a continuous loop, not a one-time project. It starts with reliable data, collecting it, preparing it, and turning it into useful features. From there, teams train models, track experiments, and version the results, so decisions are reproducible. After deployment, the model is served and monitored in production. When performance drifts, new data arrives, or business goals change, the system feeds that learning back into retraining and improvement. Every ML system starts with raw data, often from databases, APIs, cloud storage, files, or event streams. Before training, that data needs a reliable pipeline: schema validation, duplicate removal, missing value handling, format transformations, labels, and feature creation. In MLOps, this work should be automated and version-aware, so teams can reproduce exactly what trained a model. Poor data can make even correct model code produce unreliable results. In Stage 2, prepared data becomes candidate models. Each training run combines a dataset version, code version, and hyperparameters, then produces outputs such as the model file, metrics, plots, reports, and other artifacts. Because teams test many variations, experiment tracking is essential. Tools like MLflow capture each run, compare results such as accuracy and F1 score, and show which model is strongest and how to recreate it later. Once a model is trained, treat it like a release artifact, not a loose file. Versioning records each candidate along with its data, code, metrics, and artifacts. The registry adds governance. Teams can compare results, run validation checks, approve promotion, and see what is actually running in production. Stages like development, staging, production, and archived reduce ambiguity and make rollback or audit much easier when a model changes. A trained model becomes deployable only when other systems can call it. Typically, we wrap it in a small API with FastAPI or Flask, exposing an endpoint like post-predict. Docker then bundles the API, model artifact, runtime, and dependencies into one container image. That image is pushed to a registry, such as ECR or Docker Hub, so the same package can run consistently in development, testing, and production. Deployment turns the model package into a usable service. A request may come through an API for real-time prediction, or data may arrive in scheduled batches. Kubernetes runs the serving containers, scales them as traffic changes, and helps replace unhealthy instances. The cloud layer provides compute, storage, networking, and security around the service. In production, the priority is control. Test each release, manage versions, monitor behavior, and keep rollback paths ready. Production monitoring has to look beyond whether the service is alive. Latency, uptime, errors, CPU, and memory show whether the system is healthy. Accuracy, confidence, drift, and business KPIs show whether the model is still useful. When thresholds move from green to yellow or red, alerts trigger investigation before users feel the damage. Tools like Prometheus, Grafana, cloud monitors, and ML platforms turn these signals into action. Retraining is how MLOps turns monitoring into improvement. When drift appears, performance drops, new labels arrive, or a business rule changes, fresh data moves back into the pipeline. But retraining does not mean simply training again. The candidate model must be validated, tracked, compared with the current production model, and approved before deployment. If it is not better, the existing model stays in place. The loop improves performance while preserving control. A mature MLOps workflow is a connected toolchain. Git, GitHub, and GitLab protect code history and collaboration. MLflow captures experiments, artifacts, and model versions. Docker packages the model and its dependencies, while Kubernetes helps run it reliably at scale. CI/CD systems, registries, and cloud storage move assets between stages. Monitoring tools close the loop by showing how the deployed model behaves in production. In production, MLOps, Cloud, CI/CD, and Kubernetes work as one delivery path. Cloud providers supply the core services: storage, compute, registries, clusters, databases, and monitoring. A code change triggers CI/CD to test the project, build a container, push it to a registry, and deploy it automatically. Kubernetes runs the model service, balances traffic, scales replicas, and supports rolling updates. This is where DevOps discipline turns ML into reliable software. Inference is usually served in two main ways. Batch inference runs predictions on a schedule, often over large datasets, so it works well for reports, recommendations, and offline scoring. It optimizes for throughput and cost. Real-time inference responds immediately through an API, which matters for fraud checks, personalization, or chat systems. It optimizes for low latency and availability. The choice depends on freshness, response time, and business impact. Imagine releasing a new fraud detection model to only 10% of traffic, while 90% stays on the current version. That canary release gives you a safer test in real conditions. Monitoring compares prediction quality, latency, errors, drift, and business impact. If metrics look healthy, you gradually promote the model to full traffic. If risk rises, you roll back quickly. Over time, those same monitoring signals feed retraining, so the model can adapt as behavior changes. You now have the full MLOps map. Prepare data, train models, register versions, deploy safely, monitor behavior, and retrain when reality changes. The tools support the flow, but the real skill is connecting them into reliable patterns. Next, we turn this lifecycle into a working ML deployment journey.